In this video, we'll learn about the most common humidifiers used in the commercial industry and how they work. We'll review the differences between humidifiers and learn the meaning of humidity and relative humidity. First, we'll look at what it takes to provide for a direct steam system. We'll need a steam boiler to provide the steam for humidification. Then we'll need to connect a water line to the boiler and then a gas line for a gas-fired steam boiler. Then we'll need a main steam pipe to distribute steam throughout the building wherever it's needed. These pipes are expensive to install because of the added cost of expensive insulation to prevent anyone from burning themselves if they were to touch the steam pipe and to protect a loss of steam. Then, most likely, we'll want to use a condensate return boiler feed water system of some type, so as not to waste the condensate which has already been heated. Then we need to pipe the condensate return piping, which basically follows the steam piping, as we'll need steam traps at every piece of equipment and every so often to remove condensate that occurs in the steam piping. We'll need to run conduit and wire over to the steam boiler to provide power to run the boiler and controls. If the project has all of this, then the first choice for adding an humidifier would be the direct steam type, as everything you need is already in place. All we need to do is install the direct steam manifold or distribution tubing into the duct or air handler, then connect to the main steam piping, and then to the main condensate return. This is a simple system of all the major equipment is already installed. Next, we can go with a steam-to-steam humidifier. Often there are concerns about breathing in chemicals from the water treatment used in a direct steam humidification system. To avoid this issue, a heat exchanger is put between the boiler and the humidifier, separating the two water systems. We'll install a steam-to-steam heat exchanger, which keeps the boiler steam separate from the steam made for humidification. The steam from the boiler will boil water on the secondary side of the heat exchanger, which is used for humidification. We'll need to run the water piping to the humidifier so as to provide a source of water to vaporize into humidity, as we're not using the steam boiler water on this option. Next, we'll connect the steam piping from the steam boiler to the primary side of the heat exchanger to provide a source of energy to boil our secondary water. We'll connect the condensate to return the steam that condenses during the process. We'll install a steam manifold or distribution tubes into our duct or air handler. Then we'll connect the secondary side of the heat exchanger to the manifold to provide our steam for humidification. With the electric steam humidifier, we don't need the steam boiler to produce steam. We can also remove the condensate return system. Next, we can remove the main steam piping. Since we are using electricity to generate steam, we need to add a disconnect switch and electrical conduit and wire from the electrical panel. Instead of a condensate receiver or boiler feed water system for the return of the steam condensate, we'll use a drain cooler. Check with your local code, as some jurisdictions don't allow dumping steam condensate at 212 degrees Fahrenheit, 100 degrees Celsius down a drain. Often you need to temper the condensate temperature to bring it down to around 140 degrees Fahrenheit, 60 degrees Celsius, before discharging it into the sewer system. The drain cooler will require a cold water connection and drain piping to an approved waste receptor. Next, we'll install a gas steam humidifier. We won't be able to use this electrical humidifier heat exchanger, so that gets removed. We also remove the electrical, as it's more power than the gas humidifier will need. Next, we remove the drain cooler, as some of the gas steam humidifier manufacturers incorporate a water tempering feature. We'll install the gas humidifier. This can be installed indoors or outdoors. Now we'll have to run the gas piping to the humidifier, as this is our source of heat generation. Then we'll install the humidifier manifold or distribution tubing into the duct and connect the steam piping to it. We'll need a small electrical circuit for the control of the humidifier. Next, we'll need to extend the drain line to the approved waste receptor, as we have removed the condensate receiver from the previous option. If the gas humidifier is installed indoors, you'll need to run a combustion vent to the outside. Another option is to use an evaporative humidifier that can be installed in an air handler or in supply or exhaust ductwork. Air passes over the media as water trickles down over it, causing the air to be cooled while increasing its relative humidity. Moisture is evaporated into the air, passing over the wet media, providing an increase in the water content of the air. Sensible heat from the supply air is used for evaporation of the water into vapor. This provides for cooling of the air while also adding moisture. This reduces energy consumption without the need for boilers or gas-fired units that burn fossil fuels for the evaporation process. To install this system, we need to remove the following: the gas piping, the steam condensate system, heat exchanger, steam piping, and humidifier manifold. The HVAC contractor will install the evaporative humidifier in the duct as shown here. Then connect the electrical power to the water pumps and controls. Then install the water piping to the unit. It's important to provide some form of water filtration to keep the unit from clogging or minerals from depositing on the equipment. We'll need a drain line to remove any unevaporated water. Also available is the ability to remotely monitor this system through a BMS system. You can monitor or make changes to the settings. This is typical with most of the humidification systems. We show this evaporative humidifier installed in the supply duct, but they're also made for installation within the air handler or on the exhaust side with the use of an energy recovery heat exchanger. There are other versions of evaporative humidification process used for non-ducted applications. Most of the humidifiers will use some version of the following controls. First, we have an air proving switch or sail switch, which is a device that confirms the fan is running and that air is blowing in the duct or air handler. You don't want the humidifier on if the fan isn't running, as this could create a lot of water accumulating on surfaces around the humidifier. You could also use a pressure switch that senses an increase in pressure in the duct. Next, we have a humidistat that prevents relative humidity from exceeding your maximum set point. For this VAV application, we set it at 90%. Relative humidity has been found to be an important factor in the control of airborne infectious diseases, reducing influenza and other viral outbreaks. As this chart shows, bacteria and viruses love the humidity to be under 40% or above 60%. This is where they thrive. The same for respiratory infections and asthma. This is why controlling relative humidity is important. ASHRAE recommends relative humidity be kept in the range of 30% to 60% for human comfort and health. Humidification is the process of adding moisture to the air to improve health and comfort, avoid high static conditions, and protect processes or products like museum paintings. Understanding psychrometrics, we know that when cold air is heated, the relative humidity drops and the air feels dry. The relative humidity defines the amount of moisture in the air at the current temperature compared to the amount it could hold at that temperature when 100% saturated. Relative humidity is always expressed as a percentage. Warmer air can hold more moisture than colder air for the same volume cubic feet of air. Warmer temperature has a greater capacity for holding water vapor. This chart shows the maximum amount of moisture that can be held in 1 cubic foot of air at the temperature shown. At 40 degrees Fahrenheit and 100% relative humidity, the air can only hold 2.86 grains. But as the temperature increases, say to 70 degrees, the air can now hold 8.06 grains per cubic foot of air. And at 100 degrees Fahrenheit, the air holds 19.9 grains. So the warmer the air, the greater its capacity to hold moisture. Keeping the relative humidity between 40% and 60% for human comfort and safety is the ideal setting. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.